share screen and let's see if the lag is gone. Right. So everybody is seeing, what are you seeing right now? All right, nice. Hopefully it will not be laggy now, right? So let's see, right? So I draw a line longer than 10 centimeters. It is laggy. Oh my God. All right, but I'll work with it, right? It's less laggy. I could at least use it. Now I'm gonna stretch, and I can't reach 10 here. Way, boy, I can't reach 10, boy. For real. All right, well, you know what? I know what I'll go do. I'll do 9 here, which I'll have to ratchet. But you will reach 10 when you're doing it, right? And if this is the beginning of the line here, I will start from the 1 centimeter point here. So you see the ratchetness I'm doing? I'm so sorry about this, guys. It's just the software. Right? The software not allowing me to get to 10. So from the end of the line to here is 10 centimeters, and I will come back across. I like that high note, so falsetto, you know. And I'll come from this 9 centimeter mark here, and I will cut that over there. Right, so now this is my 10 centimeter line. So this here, oh crap, just now. I need to reassign something here with area, display 1. Yes, display 1, thank you. Okay, good. Right, so this here is the line B, C, and this is 10 centimeters. Now I want this BA to be 6. So what I'll do is I'll come by my compass, open the compass here to be 6. So I'll open the compass at 6. Now I'm gonna put that at the point B. And I don't know what the angle of BA is supposed to be. So I'm just going to draw an arc. And remember, the distance of this arc from the point B will always be 6 centimeters, right? So no matter what line I draw from B to meet that arc, that line will always be 6 centimeters. Right? Now I want the 8 centimeter line from the point C. So from the point C, I will come here with my compass. I know I could at least get 8 centimeters. I'll measure 8 centimeters. And now I'll come from the point C now. And I will draw an arc, an 8 centimeter arc to meet that 6 centimeter arc. And so we could see here that where the point where these two meet, right, the point from here to here, that will be 8 centimeters. And then from this point coming here, that will be 6 centimeters. So this is 6. This is 8. And let's measure this angle, because this is the angle they want. 10, 20, 30, 40, 50. I would say about 54 degrees. Now, for this question, they will give you a margin of error 54, 55, 1, right? And now we just have to do the same thing, because remember, what do they want? They want another line 6 centimeters here and another line 8 centimeters here in order to complete this parallelogram. So you just go and you do the same thing, because I think I'll run out of room, so I might not be able to do it. I will run out of room under here, right? But I'll just try to see, right? So they want another line 6 centimeters, right? So I will come here, I'll just measure back the 6 centimeters to this arc there. All right, so that is, that is the 6 centimeter arc. And I could draw another arc at the bottom. You see how I'm going off the page? I'll come back on this side. I'll do the other 8 centimeters. So let me just readjust this to the 8 centimeter arc. So this one, yeah, so it cutting right about there. I just off of my page there. But essentially, if you join this B to here, and then you join this C to here. We now have the quadrilateral, and down here, somewhere right here, will be the point D, and this will be 6 as well. This will be 8 as well, and this is the quadrilateral. Any questions? I know it was a bit shaky, and I know we wasted a lot of time because of my technical difficulties and computer errors, but apologize about that. I will just do all the rest real quick, right? So, because how much questions we have again? 1 and then just 2. So just 2 questions after. I will want to talk to you guys about the next 2, so I will just do this one real quick, right? The diagram not drawn to scale shows a block of metal in the shape of a prism. The cross section of the block is a trapezium. So I could see the trapezium here, right? PQRS with parallel sides QR. So they're telling me that these 2 sides, QR and PS, are parallel, right? And PQ, the perpendicular distance between the sides. So PQ is perpendicular between the sides. So you could see that here. Remember, or right now, just by reading this, all of those thoughts of parallel lines should be coming through your brain, right? I seen somebody in the chat there. All right, BRB, don't take too long, right? PQ is 15, yes. QR is 6. PS is 12. ST is 3, sure, no problem. Calculate the area of the trapezium PQRS. So the area of a trapezium is a half the sum of the parallel sides times the perpendicular height. They just want the area of this space here. So we're not dealing with the tree. This tree have nothing to do with it. Right? We're just talking about this trapezium here. The sum of the parallel sides, so that is the 12 and the 6, times the perpendicular height. Well, we can see that 15 is perpendicular to both parallel sides. So we have a half of 12 plus 6 times 15. 12, 13, 14, 15, 16, 17, 18. So a half of 18 times 15. So a half of 18 is 9 times 15. Anybody want to tell me what's 9 times 15? If they want to leave early? 135. Thank you. Centimeters squared. You have to put centimeters squared or they will penalize you, right? So we have the area of the trapezium. Given that ST is 3 centimeters, calculate the volume of the metal block. Well, that's just really simple. Volume is just the area of the base, which is this, times the height. So now we're going to need the tree. So now we have the volume being the 135 times, this is the area of the trapezium, times the perpendicular height 3. And what is 135 times 3? So that is 405 centimeters cubed. Right. Given that, all right, is that it? All right, the block of metal has a mass of 1.5 kilograms. Calculate in grams, another conversion thing. The mass of 1 cubic centimeter of block of metal has a mass. So this entire volume here, so this volume, the block of metal, right, has a mass of 1.5 kilograms. So 405, that volume there, has a mass of 1.5 kilograms, right? Calculate in grams the mass of 1 cubic centimeter of metal. So 1 centimeter cube of metal will be 1.5 kilograms all over 405. So 1 cubic centimeter is equal to Well, they say in grams. How many grams are in a kilogram? Well, kilo is 1,000. So we should change this to grams one time. We don't have to actually, But if we go 1.5 divided by 405, you're going to get a kind of ugly answer. You're going to get 0.0037 kilograms. And then you multiply this by 1,000 to get grams. So 1 centimeter cube is 123. So that will be 3.7 grams. Yes, that is it. So if we look at this, the diagram below, not on the scale, shows this pentagon is a 5-sided figure. The pentagon YZ is parallel. So let's just see. We see in here that YZ, this is YZ here is parallel to this. So these two are parallel, and these two are parallel. You can see that. So we're dealing with parallel lines here. The angle 114 here, and then we have an angle of 98 here. Determine the value of the angle WXY. So WXY, that is this angle here. Can anybody give me that angle? Yes, very good. So these two are parallel lines. That means that this transversal and these two will be co-interior angles, and co-interior angles do add up to 180 degrees. So the value of that, do they say give reasons? No, but you should, well, 1 mark, so I guess you don't have to give the reason. Because it is 1 mark, but you should always give the reason just in case. 180 minus 114. Yeah, this is paper 2 questions, so you could use a calculator here, right? So 66 degrees, and just put co-interior just in case. Just in case, right? Because it could be a half mark for this and a half mark for that. Okay, so just in case. Always put your reason in. Next question, the angle ZVW. So ZVW. This is an interesting one. This angle here. How are we going to find that? What? This? No. Vertically opposite angles is when you have this situation. This is vertically opposite to this. Yeah. However, I have another way to work at it. So Sabira, yes, you're absolutely right. She remembered that the interior angles of a pentagon will be 540. It's 540? Yes, it is. Right? So it'll be 540 minus all of these. What did you get when you add up all of these, Sabira? What did you get when you add up all of these? 390. So what did you get when you minus 540 and 390? 150 degrees. Does this look 150-ish? Yes, it does. Yes, it does. Is there any other way? Because what if a student can't remember what is the interior angles of a pentagon? So, if you want, you could imagine extending this and extending this. Right? That means that this angle here will be 66. This angle here will be 98 minus 180 minus 98. 180 minus 98. And that is 82. So we'll have 82 over here. Right? And so we have 82 plus 66, which is 148. And 180 angles in a triangle minus 148 means that this angle here, what? I get 32? Just now I do something wrong. 180 minus 98 is 82. 82 plus 66 is 148. So this 82 plus 66, that giving me 148, right? Angles inside a triangle. Also, it's supposed to be 392 here. I was wondering, I was studying if something was going wrong with me, right? So you see, the other way helped us to, um, because then that means that this would have been 180 minus 140, which is 32. And so now this angle here will be 180 minus 32, which is 148. So this is actually 104. So as actually 148 is the final answer. That's what you got. Last question. I will do the last question and I will let you guys go, right? So we have this, it's a quadrilateral. Q is a point on PT, I can see that there, such that QT is equal to QR is equal, so all of these are equal and they see those equal signs there. And that angle is 76. Determine, given reason for your answer, and how much, you see they're given 2 marks here now. So reason, they were a good reason. Okay? Given reason for each step of your answer, the measure of angle RQT. RQT, you want this. So at the end of the day, if these two are equal, right, that means that this is an isosceles triangle. So that means that this here is 76 degrees, because the base angles of an isosceles triangle. So the first thing I'll put is that the angle at T, the angle at the point T will be 76 degrees, because base angles, I hate this word, isosceles, I sure I spelled it wrong, and I spelled it wrong? Yes, it have another S here, isosceles, right? So base angles of isosceles are equal, and therefore RQT will be 180, those are the angles in a triangle, minus 76 by 2, 76 by 2, 152. So I'll put 76 by 2, so that's 180 minus 152, which is 28. So this will work out to be 28 degrees. Any question? And of course, we should put here angles in a triangle equal 180. So you have 2 reasons here. So I would say, so you can see here that with a question like this, you're generally getting half of a mark. Half mark for an answer, half mark for a reason, half mark for this answer, and half mark for this. Last 2, let me go real quick. Angle PRT. PRT. Am I reading that correct? PRT. So PRT is this here. PRT. So that means that I need to get this small one and add it to that 76. Am I sure I'm reading that right? Angle PRT, yes. So that means, well, I can see here that this being equal to this is also an isosceles. And so, therefore, it being isosceles means that this will be equal to this. These 2 will be equal because the base angles of an isosceles are equal. And so this angle I could find, so let's, and I'll do it on this side because I don't want to lose the diagram, right? So, so angle RQP is 180 minus 28, and you could just put straight line. So angles in a straight line is 180, right? So 180 minus 28 is 152. 152 over here. Now I could see that therefore 180 angles in a triangle minus 152. 180 minus 152 is 28. And this is angles in a triangle add up to 180 degrees. So therefore, these two angles are equal and they add up to be 28. So therefore, angle PRQ will be 28 divided by 2. What's 28 divided by 2? 14. So that is 14 degrees here. So this is 14, this is 14, and the reason for this is base angles of isosceles are equal. Base angles of isosceles are equal. So now I get that for 14. So now I just have to say, well, alright, angle PRT. No reason for this. This is pretty self-explanatory. 14 plus 76. 90. Wow, that's a 90-degree angle. It'll look at 90-ish, you know. It'll look at 90. Alright, last one, guys. Last one. Alright. Angle SPT, given that that angle is 145 and that angle is 100. All right. So what I want angle SPT. SPT. So this is the angle I want here. SPT. Given that SRT is 145. So this whole thing is 145. SRT. So this whole angle is 145. And what else they give us? PSR. PSR. Oh gosh. PSR is 100. So I mean, if this whole thing is 145 and this is 90, well, then that means that this little bit inside here will be 145 minus 90. 145 minus 90 is equal to 55. So I have 55 inside of here. Right? This is 100, and then this angle here will be 180 minus these two added up, which is 155. So 180 minus 155 is 25. So that means this will be 25 here. And that means that 25 plus 14 means that this here works out to be 39 degrees. And I didn't really write the reasons for that one because I was just trying to finish it off quickly. But you know, it's pretty self-explanatory. Right? That one was pretty easy because they gave you some additional angles. That is it for our geometry review.